Welcome to Unit 2, Lesson 16, Solving Systems by Elimination, Part 3. Our learning goal in this lesson is to find out how multiplying equations by a factor can help us solve systems of linear equations. We have two learning targets for this lesson. Number 1 is for you to be able to say, I can solve systems of equations by multiplying each side of one or both equations by a factor, then adding or subtracting the equations to eliminate a variable. Learning target number 2 is for you to be able to say, I understand that multiplying each side of an equation by a factor creates an equivalent equation whose graph and solutions are the same as that of the original equation. Our first glossary term is elimination, a method of solving a system of two equations in two variables where you add or subtract a multiple of one equation to another in order to get an equation with only one of the variables, thus eliminating the other variable. Our next glossary term is equivalent systems. Two systems are equivalent if they share the exact same solution set. Our next glossary term is solution to a system of equations, a coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. Substitution. Substitution is replacing a variable with an expression it is equal to. System of equations. Two or more equations that represent the constraints in the same situation form a system of equations. As we start the practice problems for Unit 2, Lesson 16, remember that our goal in this lesson is to use elimination by first multiplying one or both of the equations by some number so that it sets up elimination by adding or subtracting. So as we look at number 1, I have 2x minus 4y equals 10 on the top, and I have x plus 5y equals 40 on the bottom. I notice that if I multiply the bottom equation by -2, then that will set up elimination by adding, because 2x minus 2x will go to 0. So that's what I'm going to do here. I'm going to multiply everything in this equation by 2. So this will give us 2x minus 4y equals 10. Oh, I want to multiply by -2. So -2 times x is -2x. -2 times 5y is -10y. And -2 times 40 is negative 80. Now, if I add these two together, 2x minus 2x is 0, so that goes away. Negative 4y minus 10y becomes negative 14y. And 10 minus 80 becomes 70. Now, the opposite of multiplying by negative 14 is dividing by negative 14. Negative 14 divided by negative 14 is 1, so this just becomes y. This should be negative 70. Let me fix that. Now, negative 70 divided by negative 14 is going to be 5. So we know that our y value is 5. Now we can substitute this value for y back into the original equations and solve for x. I'm going to use the bottom equation since it has x by itself. So this means we would have x plus 5 times y, which is 5, equals 40. 5 times 5 is 25. And the opposite of adding 25 is subtracting 25. So we're going to do that to both sides. Now, we have x. 25 minus 25 is 0. And 40 minus 25 is 15. So the overall answer is that x equals 15 and y equals 5. This is the point that solves both equations, and if you were to graph them, it is the point at which they would cross. Now let's try it with number 2. In number 2, we have 3x minus 5y equals 4, and we have negative 2x plus 6y equals 18. I don't see any quick eliminations by multiplying just one of them, but I do know that if I multiply the top equation by 2 and multiply the bottom equation by 3, then this will give us 6x on the top and negative 6x on the bottom and allow us to use elimination. So 2 times 3x is 6x. 2 times negative 5y is negative 10y. And 2 times 4 is 8. On the bottom, 3 times negative 2x is negative 6x. 3 times 6y is 18y. And 3 times 18 is 54. Now if we add them together, 6x minus 6x becomes 0. Negative 10y plus 18y becomes 8y. And 8 plus 54 becomes 62. The opposite of multiplying by 8 is to divide by 8. So we're going to divide both sides by 8. 8 divided by 8 is 1. So we just have y. And then 62 divided by 8 is 7.75. Now we can take this value of y and substitute it into either of the original two equations. I want to work with a positive x, so I'm going to substitute it into the top equation. This will give us 3x minus 5 times y, which is 7.75, and that should equal 4. Five times 7.75 equals 38.75. So that is minus 38.75. Now, the opposite of subtracting 38.75 is to add 38.75. So we're going to add that to both sides. Negative 38.75 plus 38.75 is 0. And 4 plus 38.75 is 42.75. The opposite of multiplying by 3 is dividing by 3. 3 divided by 3 is 1, so this just leaves us x. And 42.75 divided by 3 equals 14.25. So the overall answer is the point where x is 14.25 and y is 7.75. These values make both equations true, and on a graph, they are the point at which these two lines would cross. If you have any questions about this practice problem, please use class time to ask for further clarification before we move on. Practice problem number 2. Tyler is solving this system of equations. He can think of 2 ways to eliminate a variable and solve the system. Multiply 4p plus 2q equals 62 by 2, then subtract 8p minus q equals 59 from the result. The other is to multiply 8p minus q equals 59 by 2, then add the result to 4p plus 2q equals 62. Do both strategies work for solving the system? Explain or show your reasoning. So first, what we're going to do is we're going to take the top equation and we're going to multiply it by 2. So 2 times 4p becomes 8p. 2 times 2q becomes 4q. And 2 times 62 becomes 124. Now, if we subtract the bottom, this would become minus 8p plus q equals negative 59. Because when we subtract, we need to change the sign of everything in that equation. Now, 8p minus 8p is 0. 4q and q is 5q. And 124 minus 59 is 65. This allows us to eliminate the p. So we could solve this problem this way. Now we could solve for q, take that q, substitute it back into the originals, and solve for p. Now the other thing he said to do was multiply the bottom equation by 2 and then add them together. So if we do that, the top stays the same. 4p plus 2q equals 62. 2 times 8p is 16p. 2 times negative q is negative 2q. And 2 times 59 is 118. Now when we add them together, 4p and 16p becomes 20p. 2q and negative 2q becomes 0. And 62 and 118 becomes 180. This method eliminates q. So the answer is yes, because each method eliminates one of the variables. And allows us to find the other. So many times there are multiple ways to reach elimination and then allow you to find the variable you didn't eliminate and then substitute that value back into the original equations and solve for the variable that you eliminated in the first place, thus finding your solution. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move on. Practice problem number 3. Andre and Elena are solving this system of equations. Andre's first step is to write 3x equals 9x minus 30. Elena's first step is to create a new system. Do you agree with either first step? Explain your reasoning. So if we look at Andre took the y equals 3x, and because 3x equals y, Andre just simply substitutes it in for y on the second one and creates 3x equals 9x minus 30. This is using substitution. Now on Elena's, What Elena did was take the entire top equation and multiply by 3. 3 times y gives you 3y. 3 times 3x gives you 9x. And now, if Elena subtracted the bottom equation from the top equation, the 9x minus 9x would eliminate and leave you with just y's to solve for. So this is elimination. So my answer would be both are correct. Andre uses substitution. And Elena uses elimination. Both will get the same answer. But I prefer Andre's substitution method. And in math, this happens quite often. There are usually multiple ways to solve a problem, especially as you get higher into upper level math. You're going to have multiple different ways to approach a situation. You want to pick the method that makes the most sense to you and that works best for you. If you have any questions about this practice problem, please use class time to ask for further clarification before we move forward. Our next practice problem says select all systems that are equivalent to this system. So the first thing I want to point out is anytime we see that select all, that means we need to check each one because there can be more than one correct answer. So if we want systems that are equivalent, then we need to make sure that the equations are equivalent. So as we look at A, on the top one we have 6D, which doesn't change, plus 4.5E, which didn't change, equals 16.5. So the top equation is the same. Now we look at the bottom equation. We went from 5D to 45D, so they multiplied by 9. We went from 0.5E to 4.5E, so again, they multiplied by 9. But we maintained the 4 on the right side. So, forgot to multiply 4 by 9. So A is not an equivalent system. Now let's look at B. They went from 6D to 30D, so they multiplied by 5. They went from 4.5E to 22.5E, so they again multiplied by 5. And they went from 16.5 to 82.5, again multiplying by 5. The bottom equation did not change, multiplied both sides by 5, so this is an equivalent system. Next, we can look at C. They went from 6D to 30D, so they multiplied by 5. They went from 4.5E to 22.5E, so again they multiplied by 5. And they went from 16.5 to 82.5, so they multiplied everything by 5. So we're good on the top one. If we look at the bottom, they went from 5D to 30D, so they multiplied by 6. They went from 0.5E to 3E, so they also multiplied by 6. And they went from 4 to 24, so again they multiplied by 6. Because they took both equations and created equivalent equations, this is also an equivalent system. Now we can look at D. We stayed at 6D on the top. We stayed at 4.5E on the top, and we stayed at 16.5 on the top. So nothing changed, so that's okay. They went from 5D to 6D on the bottom, so they multiplied by 1.2. They went from 0.5E to 0.6E. Again, they multiplied by 1.2. And they went from 4 to 4.8 on the right. Again, you can do this by multiplying by 1.2. So they multiplied both sides of the bottom by 1.2. This creates an equivalent equation. Since the top equation stayed the same and the bottom equation is equivalent to the bottom equation in the original, this is also an equivalent system. Now we can check E. They went from 6D on the top to 12D, so they multiplied by 2. They went from 4.5E on the top to 9E on the top, so again they multiplied by 2. And they went from 16.5 on the top to 33 on the top, so they multiplied both sides by 2 on the top. Now we check the bottom. They went from 5D on the bottom to 10D on the bottom, so they multiplied by 2. But they didn't change the 0.5E. And then they went from 4 to 8 on the bottom by multiplying by 2. So they forgot to multiply 0.5 4.5e by 2. Because this is not an equivalent equation, that means it is not an equivalent system. And finally, we're checking F. On the top, the 6D stayed the same, 4.5E stayed the same, and 16.5 stayed the same. So the top equation has not changed. On the bottom, they went from 5D to 11D. This could be accomplished by multiplying by 2.2. They went from 0.5e to 5e, which happens by multiplying by 10. And they went from 4 to 20.5, which can be done by multiplying by 5.125. So they didn't multiply everything together. If I look at them, what they actually did was add the two equations together and then replace the bottom with the new equation. 6D plus 5D becomes the 11D. 4.5e plus 0.5e becomes 5e, and 16.5 plus 4 becomes 20.5. When you add the equations together, you get a new equation that has one of the same answers as the others, but it does not create an equivalent equation. But they did not create an equivalent equation, so that is not an equivalent system. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our last practice problem says here is a system of equations with a solution. Number 1, write a system of equations that is equivalent to this system. Describe what you did to the original system to get the new system. So when I look at this system of equations, the first thing that grabs my attention is that fraction, 1/2. I prefer not to work in fractions unless I have to. So to get rid of that 1/2, I'm going to multiply everything in the bottom equation by 2. So for number 1, multiply the bottom equation by 2. This will give me a new system of equations where the top stays the same, the bottom 2 times 1/2 p becomes p. 2 times 5q becomes 10q. And 2 times -5 becomes -10. I've put my bracket here, and now I have an equivalent system. Number 2, explain how you know the new system has the same solution as the original system. The top equation stayed the same. The bottom equation had both sides multiplied by 2. Because the equations are equivalent, they will have the same solutions. If you have any questions about anything we covered here in lesson 16, please use class time to ask for further clarification before we move on.